Hi everyone, welcome back to Learn with Preeti's channel. In today's section, let's learn about the important Java concurrency concept, which is read-write-lock. Okay, so I have come up with some scenarios. First, let's understand what is read-write-lock. Read-write-lock is nothing but we have one lock. Okay, multiple thread can acquire that lock and perform the read operation, whereas for the write, it has to wait until all reader threads releases the lock. Okay, this is the concept. If you see here, here I have come up with the read-write-lock, new reentrant lock. Let's first understand the fair concept, then we can go for the non-fair concept. So in the fair concept, non-fair one, so we have a read one. Here this lock, read lock, what it will do, it will try to acquire the read lock and increment the read count. As we are calling the lock, it will increment the read count to +1. Okay, and I'm sleeping for some time, and then here important, I'm releasing the lock. Next, if you see here, what we are doing, we are acquiring the write lock and then incrementing the write count to 1, and we are waiting and we are doing assignment, and then finally at the end we are releasing the write lock. So if you see here, this is a logic we have done here. Now let me go back to our main class. What we can do here, I'm commenting out these lines, and now I am uncommenting this one. Okay, yeah, so yeah, sorry guys, my bad, I had a battery issue, so I just got it. Yeah, so moving on to our topic, we have a shared resource, right? So what let's do, what we can do is we can try to this is a read task, correct? What we can do, what we can do is where is my, yeah, so what we are doing here, we are calling the read method here. Okay, and assigning it back to the read task. Now here we are calling the write with the value as 100, which is a write task. Now what first we can do is, what is our first question, can multiple thread acquire the read lock at the same time, correct? So first I will include the read lock here, and write lock at the bottom. I will replace this to reader 1, reader 2 and reader 3. Okay, now let us see what is actually happening. I'm running. Okay, so yeah, so if you see here, what is actually happening, all these are threads, correct? So all these 3 threads can execute simultaneously. In our case, what is happening, first read thread got a chance, first reader thread got a chance. Here let us add something like plus I am in writer, plus I am here. Okay, now let us run. Yeah, Here you can see what is happening. This I am here printed only. First what is happening, first reader came, first readers are executed. If you see carefully, see here, let me upgrade this to 2. Yeah, first what is happening now, let us run again for better clarity. Okay, yeah, every time if you see, this is keep on increasing, the reader one is keep on increasing, but the writer is all at the bottom only. Now let me run again. Here you can see reader 2 acquired the lock first, then the reader 3, then the reader 1. But why the writer came at the bottom? Because when the another thread already acquired the read lock, writer thread has to wait until the lock has been released by the other thread. In our example, all when reader thread get executes, when reader thread get a chance, reader to get a chance, reader to get a chance, what it will do, it's incrementing the read lock to +1, and it start executing it. At the same time, if you come back to the main, we have read task read 2. So this all 3 threads can execute simultaneously. It doesn't need to wait until the lock released by the reader thread, because read write lock is specifically meant read multiple reads can acquire lock at the same time. So this read task will go here and increment the read count to +2. The same thing for reader 3 +3. In our case, reader 2, reader 3, reader 1 got executed, while the writer thread need to wait until once a read completed for every reader thread, this finally method will be executed. When unlock is happening, the read count will be decremented. Okay, so until the read lock count lock count reaches to 0, the writer thread will be waiting. Okay, the moment it sees 0, then then the writer thread will execute. Now the next question can come in. What if the writer thread get a chance first? If the writer thread get a chance first, then no threads are supposed to acquire the reader thread. When the writer thread acquire the lock, another writer thread also should not supposed to acquire the same lock. Another reader thread also should not supposed to acquire the writer lock. Okay, let us see whether in our current example whether we are getting. Okay, here also I got at the bottom only. Let me see here, please. Okay, here also the same. So what we can do, let me do this one. I am cutting this one and pasting here, and then I am what I am doing, thread dot sleep of some 1000 milliseconds I am waiting. Okay, throwing add exception to the message signature. Now let me run this one. So writer 1 got a chance. If you have observed, it waited for some milliseconds. After that, reader got a chance. Correct. When the reader got a chance, all these threads need to wait until the writer thread releases the lock. That's why all writer 3 are executed after that one. Okay, hope you understood this one. What happens? Okay, this is can multiple thread acquire the read lock at the same time in a read lock write lock. So we have discussed just now. Read write lock can multiple thread can acquire the read lock at the same time. What happens if one thread already holds a write lock? Just now we have seen that other writer thread as well as other reader thread need to wait until the writer thread releases the lock. If a thread holds a read lock, can it upgrade directly to a write lock safely? Okay, this is a very important question. Let's see. We have this read lock, right now this object has read lock. What I am doing inside this one, lock dot write lock dot lock, then inside try I don't have anything. Just in finally, simply lock dot write lock dot unlock. Okay, so what I have upgraded the read lock to write lock, and then in finally I'm unlocking, and then I'm releasing the read lock. Can you say is this preferable or not? What will be the issue here? Say yes or no. Here the is this valid or not? Will deadlock occur here? Yes or no? Yes sir. So for this the right answer is deadlock will occur. Why that is happening? The reason is when the thread runs this one, it acquires the read lock, correct? Now it comes here waiting, and then it acquiring the write lock. As per our read write lock, it write lock will thread will acquire a write lock only when the read count reaches to 0. But as per here, what will happen? Read count will be 0. But the moment comes here, it will be 1. But the moment comes here, it tries to acquire the write lock. But write lock will be acquired only when current thread or other thread releases the read lock. But read lock already held by the current thread. So write lock will wait. Write lock will wait. So to get a write lock, we need to wait until current thread releases the read lock, correct? Now finally I am releasing the lock, but it won't come here at all. It won't come here at all. Why? Because here it is waiting to the current thread to release the read lock, but the read lock is waiting for this line to get the read lock. It is like a read one reader line waiting for writer line to complete. Writer lock waiting for reader line to complete. Reader line to release a lock. So which is nothing but a deadlock. Okay. So that's why this is, we used to say, upgrade. In read and write, the highest privilege given to write only. So we are upgrading from read to write. So in ReadWriteLock, upgrading is not at all preferable. Let's see what is the output we are receiving for this piece of code. Okay, let me see. See here, I didn't get moved out from that particular piece of block. My console is still waiting. Why that is happening? Because here first writer thread got a chance. Threader for after that all this reader threads are executed simultaneously. Now if you go here inside the read, we are acquiring the write lock. So thread reader 1 is waiting, reader 2 is waiting, reader 3 is waiting. If you see here system, to make you even better clear, let's see, I came out. I am printing this one. This line you will never see in this piece of code. See, you can see, right? It stopped. It is running. Okay. So let's see whether we are getting or not. See, that particular piece of line is not at all executed. The control stuck here itself. Okay, which caused deadlock to occur. How we can solve this problem? How we can solve this? It's not at all preferable to go for upgrade. If a thread holds a read lock, can it write lock? Why it causes just now we found the reason why it is causing a deadlock. Okay. What is downgrading in reentrant lock? So the same case we have upgraded. Now let's see whether we can downgrade. Downgrade means we need to downgrade from write to read. That we need to do in only in writer. Here we have write lock. Okay, the same piece of code I am adding here. It's 1 minute. I'm cutting this piece of code and pasting it over here. Instead of a write lock, what I need to do? I need to do read lock, because we are downgrading. I am removing the commented lines. Here also I am removing the commented lines. Now let me run this main class. See, here you can see, right? In the writer, first trying to write a value, and then I came out printed, and then reader, and then console came out successfully. Okay, it's not waiting at all. The reason why that is deadlock is not happening while downgrading is, as I mentioned, write lock is an exclusive one. It's an higher privilege given to that one. As already you have a write lock, you can go ahead and get the read lock, and you can release a lock and can do. Here in the read write lock, we had when we try to acquire the write lock, we need to wait until current thread or other thread releases the read lock. But here what we are doing in line number 31, we are only reading. Okay, so if current thread is writing, inside the current thread we can acquire the lock and we can perform the reading and we can release that lock. Okay, so this is the downgrading. Here this read lock is not waiting for the write lock to release the lock, right? So that's the reason. Here it doesn't throw the deadlock. Okay, hope that clarifies your question. That makes even clear. Now moving on to the next question. Why is read write lock useful only when reads are significant more than writes? So just now we have seen what we have discussed. Multiple threads can get the lock can acquire the lock simultaneously. Multiple threads can acquire the read lock simultaneously, but the write, if the thread wants to acquire the write lock, it has to wait until all the threads releases a read lock and the read count should reach 0. So that's why in any system, if we feel where multiple reads are involved, we can go for read write lock. Okay, moving on to the next question. What happens if many reader threads continuously acquire the read lock? Can write a starvation occurs? Yes, this will happen. Consider I have 1000 plus threads. All are performing read operation. Want to perform read operation. I am calling this read method. 1000 plus threads calling this read method. What will happen? Or 1000 plus threads will try to acquire the lock. My thread read count will reach to 1000. But to consider there is another thread to perform the write operation. It has to call the write method, correct? So to call this write method, the criteria is read count should reach 0. As we have 1000 plus read count, it has to single write has to wait until 1000 read count until 1000 read count reaches to 0, which makes writer starvation only, correct? So that's why this causes the writer starvation only. Okay. Yeah. Is read write lock re-entrant? Yes, it is re-entrant. Within the lock, we are trying to acquire the lock. In our example, we have seen, no, within the same piece of code, we are trying to, what we can do, lock dot write lock dot lock. We can do this is valid only. If let me run this one. Okay, why it stopped? Because I have not released the write lock which I have opened. My here the write count will be 0, sorry, 1. Here upgraded to write count will be upgraded to 2. But at the end of this line, what I am doing, I am included only one unlock. Write count will be 1, but ideally write count should reach 0, correct? That's the reason. So what we need to do, we need to add the same, we need to call this one. Yeah, now let me run. Yeah, here you can see, right, other lines are executed simultaneously. Hope this makes you understand better. Yeah. Okay, the next question. What is the difference between fair and non-fair in a read write lock? Okay, whatever we have seen, this is a non-fair, correct? 3 plus 1000 plus write threads we have, but only one write threads have, right? One write thread have to wait until 1000 read write gets completed, correct? This is not a fair. So to make this as fair, what we need to do, we need to include true. So if we include as true, it will give first come first serve. FIFO, it will maintain a queue, first come first serve, first in first out queue will be maintained. So already let's consider okay, let's move to our piece of code. Let's make pasting over here. Okay, yeah, here we have reader 1, reader 2, reader 3. In between I have writer 1. Let's see what is happening here. Yeah, we have included right over here with the fair. It has to ideally come, but why it is printed at the, let me run again. Let me check why this not give preference based on first in first out order. I'm checking on that. Uh, 2 minutes, let's find out the reason. Okay, it looks like this doesn't maintain the strict FIFO order. Okay, so if continuously reader one comes, it gives preference to that, it seems. So this is not maintaining a strict FIFO one. Okay. Yeah. Moving on to the next question. So yeah, with the non-fair one, uh, uh, like it maintains a queue. Based on that, it will, with the fair one, it doesn't maintain a strict FIFO, but in some edge cases it can come. That is, re-entrant read-write lock in fair mode does not guarantee strict FIFO ordering. It ensures that reads are queued fairly, but read lock or shared. So multiple readers can acquire the lock concurrently. If reader continuously arrive or active, write thread may be delayed because the lock favors allowing concurrent readers instead of strictly enforcing queue order. Hence, writer starvation or delay can still happen. Okay. Can multiple writer threads enter simultaneously read write lock? This we have seen. Answer to that is no. If current thread or any other thread acquires a write lock, the reader thread or writer thread have to wait until the write lock released by other thread or current thread, and the write count should reach 0. If a thread has read lock and thread B requests a write lock, can reader still enter? So in case of non-fair one, thread A already has a read lock. Now thread B comes in, thread B requests a write lock. Yeah, no, thread B should not acquire the lock, because as per non-fair policy, write lock we can acquire only when the read count reaches 0. That is, all other threads releases the read lock, current thread releases the lock. New thread will not enter at all for the fair, for the non-fair. Coming to the fair also, it is the same concept. Whatever thread it has, obviously the thread has to release that lock. Why is upgrading from read to lock is dangerous, but downgrading is read safe? Because upgrading is causing a deadlock, because while we update from read to write, write has to wait until the lock of current thread releases a read lock. But when we upgrade write to read no need to wait for a write lock to release. That is the reason. If you forget to release a, just we have seen some minutes before, what it will be waiting forever. Whenever we are not calling unlock method, count of read count or write count will never reach 0, so it will be in waiting state forever. This will acquire the write lock and this will acquire the read lock. It will increment the write lock, this will increment the read lock. What is stamped lock introduced? Why is stamped lock introduced when read write lock already exists? This is also one of the very important question. So why we have, if you see in the read write lock, even for the read lock we are supposed to acquire the read lock, which is not a fair, right? We are just reading. Why we need to acquire the lock? So what we have is like, there is something called try optimistic read. Okay, no lock initially. First we are seeing whether validate. What this method does, while reading some other write is happening, or already other write has happened. If that happened, it will try to get the read lock, and it will release that particular read. It will update that stamp, because it finds out that the stamp is not same. Stamp is nothing but here something kind of a token. Okay, with read it will have some stamp. Let's say here some write has happened, means this stamp will be different. So it compares both stamp. If there is any mismatch, if both are not the same, then it will get the lock of the read, and it will update and releases the lock. This is a best the good way, no. So this happens only in rare case, only if write happening in the current thread or write happened already, then only this will happen. We are not getting the lock every time, right? So this is the best example for optimistic one. Pessimistic is nothing but whatever we see in here, right? This is pessimistic. For the read one, we are trying to acquire the lock. This is pessimistic. We are trying to acquire the lock. But in optimistic, we are processing without getting the lock. Why can stamped lock outperform with reader? The reason those you should have understood it by now, because we are acquiring a lock only if it is needed in case of read lock. If we have many read operation to be done, then this would be a best example, no. Only if write happen, then only we are acquiring the read lock. If 1000 plus reads are there, in between one write happen, we no need to acquire 1000 plus read lock. When write happen, it will get only one read lock and it will release us after updating. This is the best good way, no. Yeah, biggest limitation of stamped lock over re-entrant lock. We don't have a re-entrant policy. Within the same lock, we cannot get the another lock in the stamped one. That is the main drawback. And we don't know the which thread, which lock it has acquired. So that would be the another problem. Can ReadWriteLock prevent read condition completely? No. We have seen when upgrading, we will have a ReadWriteLock. So there is one program which has been provided. We need to say the output. We have a runnable one. We are trying to acquire the lock and we are releasing the lock, and we are trying to run simultaneously. Will both thread execute together? The answer to that is yes. Yeah. At the end of this section, what we have understood, the importance of ReadWriteLock, ReadWriteLock, and then stamped lock, deadlock, how it occurs, upgrade and downgrade scenario. Yeah, I hope this helped you to understand more on data incurrency one. If you have any question, please let me know in the comment section. We can learn together. Thanks for watching my video. Have a great day. Take care. Bye bye.